Hi everyone, Kevin here. This is homework problem 15 from chapter 6 of Chem 60. I will work an example of this problem. The numbers that you will find in your version of this homework problem probably differ. So you will need to work this problem using the numbers in your version of the problem. But if you follow these steps, you should be in good shape. So let's go. So here is the chemical equation given. We've got silver nitrate reacting with sodium hydroxide to make silver oxide plus water plus sodium nitrate. And if you go on to the next part, it'll give you a scenario like this. If you mix 100 mils of 0.3 molar silver nitrate with a large amount of 0.450 molar sodium hydroxide, how many grams of silver oxide do you form? So what do we want here? We want grams of silver oxide formed from a certain quantity of silver nitrate. All right, so that's what we want. What do we have? Well, we know that we have 100 mils of 0.300 molar silver nitrate. So we're looking for grams of silver oxide formed from a certain quantity of silver nitrate. That quantity of silver nitrate we need to determine from what is given, 100 mils of 0.3 molar silver nitrate. So from that, we can calculate the moles of silver nitrate. That is, from the volume and the molarity, which is moles per liter, we can calculate the moles. From the moles, we can calculate the grams. And then we can use grams of silver nitrate plus the mass ratio of silver nitrate to silver oxide, and that will give us the grams of silver oxide that you can make from this quantity of this number of grams of silver nitrate. So this is just a mass ratio problem, but the complication is we have to figure out the number of grams of silver nitrate that we have given the milliliters and the molarity. One more thing before we start. They've added a large amount of sodium hydroxide. What that means is they've added that in excess in this first part of the problem. So sodium hydroxide is in excess. So that means all of the silver nitrate will be used up. All of it will react with sodium hydroxide. At this point, we're not worried about how much sodium hydroxide we need. We're just throwing it into the reaction mix in excess so that whatever's needed to consume all the silver nitrate is available, and all the silver nitrate will be turned to silver oxide. So, all right, let's get going. So we need to first calculate the grams of silver nitrate. So we have 100 mils of a 0.3 molar solution. So we get 0.300 moles per liter of silver nitrate. And we have milliliters in one place and liters in the other. So as part of our conversion here, we've got to replace, we've got to convert mils and liters. And so we can do that because we know 1 liter is 1,000 milliliters. And now we can cancel milliliters in that first term with the denominator in the last term, and liters cancel, and that gives us moles of silver nitrate. All right, and let's see, if we do the math, it looks like we'll end up with 0.030 moles of silver nitrate. All right, so now to get our grams, we just need the molar mass of silver. I keep saying sodium. Guess we're so used to looking at sodium this semester. So our molar mass of silver nitrate, so we have to add up the molecular weight of silver, 1 nitrogen, and 3 oxygens. So silver, if we look up the molecular weight of silver, it is 108. Silver is 108. Nitrogen is 14. And oxygen is 3 times 16 equals 48. So if we add up 108 plus 14 plus 48, we get 118, 122, 162, 170 grams, if I've done my math correctly. So our molar mass of silver nitrate is 170 grams. So we have 0.030 moles of silver nitrate. And our conversion factor between grams and moles is just our molar mass. And if we do that math, we come out with 5.1 grams of silver nitrate. 5.1 grams of silver nitrate. All right. So we've got our grams. Oh, sorry, we've got grams. Here we've calculated grams of silver nitrate. Now we use the mass ratio between silver nitrate and silver oxide to calculate the grams of silver oxide we will make from 5.1 grams of silver nitrate. Let's go to the next slide and we'll do that math. All right, we've got 5.1 grams of AgNO3, silver nitrate. We need the mass ratio of silver nitrate to silver oxide in this problem. Now, in this problem, we use 2 moles of silver nitrate to give us, and I'm not going to write the entire equation here, but it gives us 1 mole of silver oxide. Okay? So we know we need to figure out the masses of each and the ratio between the 2 masses. Okay? So we know that the molar mass of silver nitrate is 170 grams for the molar mass, right? So the formula mass, maybe we should take it a step back here, 1 step, and say our formula mass of silver nitrate is 170 atomic mass units. Our molar mass is 170 grams. Hopefully you're fairly familiar with those two terms at this point. Now, in this equation, remember that mass ratios are unique to each equation. So in this equation, we have 2 moles of AgNO3. So the mass would be 2 times 170 grams, or 340 grams in this equation. All right, let's do the formula mass of silver oxide. All right, in that we have 2 Ags, 2 silvers, and 1 oxygen. So 2 silvers we said that's 108. So 108 times 2 would be 216 atomic mass units. And 1 oxygen is 16 atomic mass units. So we've got 232 AMUs. That's our formula mass for silver oxide. So our molar mass is just that quantity in grams. So it is 232 grams. So now we have a mass ratio of 2 AgNO3 to Ag2O equal to 340 grams of silver nitrate to 232 grams of silver oxide. All right, that's our mass ratio in this particular problem. So now it's just a simple conversion. We start with 5.1 grams of silver nitrate. We multiply that by the conversion factor, the mass ratio in this particular chemical reaction between silver nitrate and silver oxide. And we want silver oxide in the denominator. So it's 232 grams. And we want silver nitrate in the denominator because we are going to cancel those units. So our grams of silver nitrate in the denominator here that I'm just crossing out now cancel with grams of silver nitrate in that first term there. And if we multiply this through and we get 3.48, get my pen going again, 3.48 grams of silver oxide. All right, and that's what we were looking for, grams of silver oxide that we could make from a certain quantity of silver nitrate. On the prior slide, we calculated that the grams of silver nitrate, and here we're just applying our mass ratio of the two. So 3.48 grams of silver oxide would be the answer to part A of the problem if you had those same quantities that I have in this example. All right, let's go on to the next slide, to the next part of the problem. In part B of this problem, we want to figure out how many mils of 0.3 molar sodium hydroxide we need to consume all of the 100 mils of silver nitrate. All right, so what this problem asks us to solve is the mils of 0.300 molar sodium hydroxide that are needed to consume all of a certain quantity of silver nitrate. Okay, that's what the problem's asking us for. what we have, well, we already calculated the moles of silver nitrate. And we also calculated the moles, the grams of silver nitrate that we're starting with. But now we can use moles, and it makes it a pretty easy calculation. So we have the moles of silver nitrate, and that equals 0.030 moles. We did that in part A. And we need now the mole ratio, and we have the mole ratio of silver nitrate to sodium hydroxide. And that mole ratio is 2 to 2. And we just get that from the coefficients in our equation, 2 and 2. So when we react silver nitrate with sodium hydroxide, the ratio is 2 moles of silver nitrate to 2 moles of sodium hydroxide. So it's 2 to 2. And we can use that conversion factor to figure out the moles of sodium hydroxide we need. So pretty easy so far. 0.30 moles of silver nitrate. That's what we want to consume. And to get the moles of sodium hydroxide, we just use the mole ratio. 2 moles of sodium hydroxide to 2 moles of silver nitrate. And we do that, and of course we get 0.30 moles of NaOH. All right, the mole ratio is 2 to 2, so the same moles of sodium hydroxide are needed as are as are the silver nitrate that we need. All right. So we've got the 0.03 moles, and now we just need to figure out the milliliters of the sodium hydroxide solution. And so we have given to us that the sodium hydroxide solution is 0.3 moles per liter. So we can just do a conversion factor that relates 1 liter to 0.300 moles of sodium hydroxide. And we're going to multiply that through. Moles of sodium hydroxide are going to cancel in these two numbers here. And we also need the answer in milliliters. So let's go ahead and add the conversion milliliters to liters in this equation. We can just be done without having to do another calculation. Liters cancel. What is remaining? The units remaining are mils, so that becomes the units in our answer. And we just do the math here. And if we do the math, we get 100 milliliters of sodium hydroxide solution. And that's our answer. That's what we needed. 100 mils of sodium hydroxide. And that's the amount of sodium hydroxide, 0.3 molar sodium hydroxide, that is needed to react all of the silver nitrate in this problem. All right, and that'll be our answer. So your numbers will differ likely when you do your version of this problem, but hopefully that helps to get you there. So thanks for watching.